I'll try to speak here, maybe in case I need to move it. Good afternoon, everyone. That's a much nicer gesture to give a plant rather than a bouquet of flowers. That stays for much longer. I would definitely plant. Keep it in my balcony, and hopefully, it will give me far more flowers than what you can give in a bouquet. Thank you for that. So happy to see all of you here. As I was so generously introduced, my name is Anoop. I'm a faculty member at IIIT, and I work in this domain. So my talk today, or the point that we want to discuss today, is on biometrics. That is, how do we recognize people based on several of their physiological or behavioral characteristics? And I called it signals of identity for two reasons. First, this is also a signal processing workshop, so there is some signal processing going on underneath biometrics, and we are trying to extract out what information is available for recognizing a person from their physiological characteristics or behavioral characteristics. So that's the goal. I'll go through it, the presentation, but at any point, if you have any questions, please feel free to ask. I'm happy to stop and answer the questions. Okay. So what are the kind of questions that are the slides visible to everybody? So what are the kind of questions that we are trying to answer in biometrics? A few type of questions are like, is this person who they claim to be? So somebody comes and claims that I am so and so. Okay. Now, the question is, how do I figure out whether that person is telling the truth or lying? Lying in this case is called by the name an imposter. Somebody is acting like an imposter for somebody else, and that's the problem. That's one kind of question that they want to answer. So there are two slight variants here, and that's very important. When I say I go and tell, in the gate when you're trying to come in, or in the exam hall when you're trying to take an exam, or when you are giving attendance every day, you are claiming to be such and such person. And how do I figure out whether you are telling the truth or not is usually dependent on some ID card and stuff like that. Okay, or in the ATM when you are trying to withdraw money, you are claiming to the bank that you are such and such person and I need money to be taken out from my bank account. And the question is, how does the bank make sure that that's you indeed? Okay, and the normal method that bank uses is the fact that you possess a card and the fact that you know the PIN number is what is taken as a substitute for who you are, that you are claimed to be. So we'll come to that. The second kind of question that you need to ask is, has this applicant been here before? So I go and take a PAN card, let's say, and then later on, if I go and try to make another PAN card, should I be given a second PAN card? Or in the case of a more common example nowadays, Aadhaar card. There are certain ID cards that are supposed to be unique, that only given to one person once, like a ration card or PAN card or things like that. So you need to make sure that when somebody comes in and says, I'm so and so, you need to make sure that not just that this person is who that person is claiming to be, but this person has not been here before, and they are not creating a new identity in the process. Okay? Or simple questions like access control. When you are trying to enter a room, if you have some kind of way to control your access, usually it is using a key. If you have the key, you can enter the room or your house, and that is the access control situation. Or another kind of situation is this person on a watch list? I have a list of criminals who are supposed to be caught, and I circulate this list among all the airports and stuff like that, so that they don't flee the country. So when any person is exiting the country, the customs officials or the immigration officials are supposed to make sure that this person who is actually going out of the country is not on a watch list. So in all these situations, there is an incentive for the person to lie. If I am trying to gain access to a room, and if I don't have actual access, then I have an incentive to lie because I get some benefits if I lie. Same thing when I'm making a ration card. If I lie and I get a second ration card, I'll get double the ration. If I'm on a watch list, I have a huge incentive. I don't want to be caught. So there are several reasons why I want to lie about my own identity. And all of you know, those are students here, why you want to lie when you are taking attendance. Okay, proxy attendance is something that all of us know about, and the incentive there is just getting an attendance. Might be small, might be large, but whatever it is, there is an incentive to lie. So the question is, how do we detect that? How do we make sure that you cannot lie about your identity? Okay, and you see this most commonly in your mobile phones. So most of your mobile phones will have some kind of a system where if you can put your finger, it might open up. And essentially, you are doing a biometric authentication, which where I'm telling that I am such and such person, and the mobile phone is making sure that you are indeed the person that you're claiming to be and given access. So mobile phone is the place where you have probably seen this most commonly or used most commonly. Every day you unlock the phone, I don't know how many times. Uh, there are studies which say that among the youth nowadays, the number of times you unlock a phone is in several hundreds per day. So hundreds of times you unlock the phone to check Instagram, whatever it is, your favorite app. Okay, uh, and there are several security concerns because of it. As we said, because there is an incentive to lie, there are security concerns like, you know, each of these access. If somebody else has given access to your bank account, of course that's a problem. Somebody else has given access to your house, that's a big problem. We try to do everything possible to make sure that our bank accounts are secure, our house is secured, locked and key and all that stuff. We don't leave our house doors open all the time. That is some form of access control. But there you are using your key to do that. And usually that's what you do. So either you use something that you have, like an ID card or a passport or a key, physical key, to make sure that the person that you are or you have indeed access to the system, or use something like what you know, like a PIN or a password. These are the most common methods for ascertaining that your identity is indeed who you claim to be. Now, because of the fact that you can actually lose your ID card or somebody else can gain access to it, somebody else can take your key, or somebody else can somehow figure out what your PIN number is. Because of it, there are a lot of security concerns in here. One of them is fake passports. If I create passports in somebody else's name, if you travel to some of the Eastern European countries or some of the European countries also, like Spain or Italy and France, there are several places where you see that pickpocketing is a big problem in those tourist cities. And one of the most uh, desirable item to be pickpocketed is your passport. If if somebody can get your passport, then a lot of things can be done with it because it's an original passport. They can just replace the photograph and then somebody else can fake a suit, and that's a big problem in several places. So Indian passports are apparently in huge demand in some of these countries because there is a lot of population of people from countries around us in those countries who would like to have an Indian passport. So it's a big issue having fake passports, and people have created crimes by using fake passports in the past. And identity theft has been, kind of this is slightly old statistics, but it has been increasing quite a lot, and the number of identity thefts have been quite large, like 13.1 million in 2013 itself. And there are some statistics here that, you know, uh, the number of hours that have been spent to rectify a loss of identity. If somebody imposters as you, somebody gets hold of your key numbers like your Aadhaar number or your date of birth, and there are a few things that are required to create a fake identity. If somebody gets hold of your identity, to recover that is a huge problem. On an average, people spend thousands of hours trying to nullify the negative effects, and the amount of money that is spent is too much. Hundreds of billions of dollars a year is actually uh, spent in fighting this one. So it's a huge problem. And the other side of it is that passwords that we use most commonly are very, very difficult. How many of you have a problem of having too many passwords and having difficulty in remembering your passwords? Almost everybody here thinks, isn't it? So it's a difficult thing to remember your password. So the most popular one is that you write it down somewhere. And the moment you write down your password, that's a problem. And also people, put very common passwords. The most popular passwords are 123456 and 12345678 and stuff like that. So in other words, if I take somebody's mobile phone and then type these two passwords, and the word password itself is the other popular password. I guess at least one of you in here might have a password of this nature. Maybe you guys are slightly better knowledgeable about these problems. But I've seen people who are professors in computer science who have been hacked because they have used weak passwords, and really big problems created out of it. I have had calls in the night uh, from some country in Africa, which saying that this professor whom I know from a nearby institute has been captured there and he is in trouble, and can you please, he's lost his wallet, everything, can you please send some money to that person so that they can come back to India. That person was happily living next doors, but all that happened was that they hacked into his email account and sent an email and figured out some of the phone numbers and started calling them. So this is a huge issue. If you don't take care of your accounts, if you don't keep your account safe, then these things can happen. Very commonly do happen. Okay. So where does biometrics come into this picture? As I said, there are several types of ways to ascertain the identity. The most common ones are something that you have, like your ID card or uh, keys. Those kind of stuff are things that you have. Things that you know are like pins and passwords. But ideally, we would like to recognize a person based on who they are indeed, not based on something that they possess or something that they know. Those are all proxies for ascertaining the identity. So that's the goal, is to figure out what is the actual identity of the person. Okay, and how do you do that? There are several ways in which you can ascertain the identity of a person. It can be based on some of the physiological or behavioral characteristics. So things like your face, your fingerprint, your iris, your dental impressions, or X-rays of your dental work can be used. This is most commonly used for ascertaining identities of deceased individuals, if nothing else is available. Even face thermogram, if you take a heat image of your face, that could be the shape of your hand, your signature. All these are usable, but what you see on the right hand side here, three of them, they are basically behavioral characteristics, like the way you walk. No, the way Charlie Chaplin walks is a very famous walk, and you can identify the person based on how they walk. And you do that all the time. You would recognize the person based on somebody whom you know. Even if that person is very far away and walking away from you, you would still recognize the person based on the way they walk. So this is very common. Or you can recognize the person based on their audio signals or your signature. These are all commonly used, and these are called behavioral characteristics because there is some physiological background to it, but there is also behavioral characteristics involved in it. The way you speak, the way you learn to speak, all these things can affect the way the sound is produced, how the sound is produced. And similarly, the way you walk. All these have a combination of physical and behavioral or habituated problems. Your signatures, they are supposed to be steady, but they tend to change over a period of time. So when did this all start? When did people start working on biometrics? A long time back. This is one of the first recorded use of biometrics for a official purpose. This was called the Bertillon system. This was introduced by a French police officer who wanted to catalog all the people who get into prisons. So the problem was that people come in as, they get caught, they get put into prison, and after some time, after serving their sentence, they go out. But if they are caught back again doing the same crime, there is a higher punishment. So what do the criminals do when they come back? They give us a different name. They give a different identity, they give a different address, and they get a shorter sentence. And the same thing is repeated. So nobody will tell the same name as second time because you get a higher punishment. So what Bertillon did is that he measured some of the physical characteristics like the height of the person, the length of their arms, size of their skull, some specific characteristics he measured, and he created this particular representation for each individual, and he stored it in a card catalog so that when a new person comes in, he will do all the measurements and then compare it against all the people who are already released after serving their sentence. And this was done manually. So they had to sit down and take cards between two people, look at the numbers and find out how similar they are. And this is, you have to go through like tens of thousands of such cards. Not an easy thing to do. But still, that was kind of the first effort. Was not a great grand success, but at least that is probably one of the first time that you tried this approach. Now, when you talk about matching, just to remind you, there are two different ways in which you talk about matching. One is one-to-one matching, and the other is one-to-many matching. One-to-one matching is usually what you do in your mobile phone. When you put your fingerprint here, what the mobile phone does is it matches this fingerprint against your own fingerprint that is stored in the phone, and that's a one-to-one matching. Whereas when you're giving attendance, when you're putting your finger, you don't tell who you are. You just take that fingerprint and match it against everybody in the institute and then figure out, oh, this is such and such person. That is a one-to-many matching. Okay, and naturally the one-to-many matching is more difficult than one-to-one matching. That's obvious. Now, why do we want to use biometrics in this case? There are certain advantages of using biometrics. One is positive identification, which is usually which is true for any kind of identification. You can say that, okay, if this person claims to be such and such person, and you can verify that whether it is true or not. Okay, so you can say whether this particular person is. If I go to my bank and claim that using my ATM card, I claim that I am Anoop, then the system can verify that because they know that this card has been issued to me. But the other kind of identification called negative identification is slightly more tricky thing. Here, the question is this person who or she denies to be? I go there and say that I'm not Anoop. Now, what ID card can you use to prove that I'm not Anoop? I say I don't have any card with me. I don't have any ID card with me, but I'm not Anoop. Now, what do? You can ask, do you know your password? I don't know. I can always lie and say that I don't know the password. I don't have any ID cards with me. And you have no way of proving that it's me. Okay? The only way in which you can do it is somebody who knows me can look at me and say that, oh, this is such and such person. I can always say that guy is mistaken. But even when they do that, they are looking at me, my physical characteristics, and deciding that it's me, which means there is some kind of biometric going on in the background. It's human recognition using biometrics, but it's still biometrics. So biometrics is the only way currently known in which you can do this negative identification. That is, if you claim not to be such and such person, I can still say that no, you are lying, you are this guy because your biometrics match. Okay? And that's very important. There are a lot of situations in which negative identification is important. You cannot, the other term related to is called repudiation. I go to my bank, I withdraw money, and then later on I come and say that I did not withdraw the money, somebody else did. You'll have to return my money. How does the bank make sure that it's actually you who withdrew the money? How can they say that no, you did some fake identity documents and withdraw the money? How do you make sure that this is not what is happening? The only way in which you can say is that, see, I have your fingerprint on record, and you put your fingerprint when you withdraw the money, and it matches, which means that it was actually you who came there, or your face, or iris, or whatever your biometric trait is that is being used. Okay, so that's one of the biggest advantages of biometrics, and this is the only method currently known which can actually do this. Of course, there are several other advantages like, but why do we use biometrics or fingerprint for your mobile phones? Why not use PIN numbers? Well, it's easier. Just that I can just put my finger here and it would unlock. I don't need to. I can do it with, while I'm holding this thing, I can just put my finger and it works. Okay, so convenience is one of the most important things. And second is I don't need to remember anything. I can forget my password, I can forget my PIN number, but I don't forget my fingers. I carry it with me all the time. Okay, it's difficult to copy. It's easy to copy your password, but not impossible, but difficult to copy your biometrics. And there are several advantages that you can do. You can do identification of people at a distance. You don't need the person to come near before you recognize who the person is. And also, most importantly, it serves as a deterrent for fraud. Once you know that your biometrics is being used, people tend not to commit fraud. That's one of the psychological deterrents that is there. Okay? So now that we know what biometrics is, we'll just take a quick look at what are the essential characteristics of biometrics that is needed. Number one characteristic or important factor that you need is what you call as uniqueness. That is, if I want to use a biometric for identification of a person, then that biometric should be unique in the sense that if I take two of you and take your fingerprints, they should not match. Okay? If you take your height as your biometric, it's possible that two people will have the same height. At least if you're rounding to the nearest centimeter, then it's quite likely that your two people will have the same height. So height is not a biometric that can be used for identification. Whereas fingerprints are, because if I take two fingerprints of two different people, they will never match. So uniqueness is extremely important. Identical twins usually tend to look alike. Your faces tend to be very similar. Even your DNA, by definition, identical twins are the same DNA. That's how you define identical twins. Two people with the same DNA, they are identical twins. So there are identical and non-identical twins. We'll come to that. But even DNA can be the same, but something like fingerprint would still be different. So it's important that this uniqueness is present in the biometric characteristics that you pick. Second is persistence. That is, if I take your biometric at the age of 7, at the age of 17, and the age of 40, these examples, it should be the same. It should not change over a period of time. Even if your fingerprints are worn off, if you're doing hard labor on the ground, you're a farmer or you're a worker in a factory or you're a carpenter, it's possible that your fingerprints will start wearing off. But if you stop doing the hard labor, whatever fingerprints that grow back would be identical to what it was before. It wouldn't change. Okay? That's very important for ensuring that you can be recognized at a later date. So the most popular one that I used are, all of us know that fingerprint is used, face is used, face unlock is popular in mobile phones, and iris also. Very few phones have got iris capture systems, but some of them had, like my previous model of this phone had a iris unlock. So when I look into it, it actually captures my iris, not the whole face, and unlocks it. But now that did not catch up much. So Samsung gave up on that after some time. But that's one of the technologies that have been developed. It is quite useful, quite unique. We will talk about that later. So these are the most popular ones. There are others which are capable of one-to-one search, like your palm print, your prints on the palm, not just on the fingers, and also your DNA. As I said, except for identical twins, DNAs will be unique among the people. So that's one of the most those are the most popular systems. There are others also which are used for one-to-one matching, like the palm veins, the blood vessels that go underneath your palm, either on this side or this side. Both can be used, and they have been used in some of the access control systems in airports and ATMs and so on. And your handshake, your signatures, it's quite commonly used to validate your checks, your voice prints, and things like that. So there are several other traits that have been used, all kinds of strange biometrics. Some of them that you wouldn't think that it's actually useful, but there might be some very specific cases in which that can be useful. One of the strange, we used to joke about some of these biometrics, saying that somebody developed a system based on tongue print. Your How does your tongue look like, and based on that, can you recognize? The problem is that how do you unlock a room? Every room that you go, you'll have to open your mouth and stick your tongue out to be recognized. It's not a very uh, maybe socially acceptable way of recognizing the people. Okay, but some of them might actually be useful in specific cases. Like one of the examples that I had was that there is this biometric system that somebody had proposed long time back, never actually developed a system for it, for lip prints. How does your lips look like? There are small patterns on your lips. Can you recognize the person based on that? How many of you would want to go and put your lips against a sensor to be recognized? That doesn't sound very good. It's not even hygienic. All kinds of problems are there. Okay, so why would you develop such a system? Apparently, there is a particular use case in which that is very useful. It was for dispensing of medication for elderly people. Elderly people who kind of forget or which medicines to take. They wanted to use this one company which wanted to use this, where you put the dispenser into your mouth, and based on the lip print, you make sure that it's the right person who is taking it, and based on the time and date, they would dispense the right kind of pill into the mouth. And that's the only one which can make sure that somebody else is not using it, because the pill would be dispensed only when you put this whole thing into your mouth. So there might be some very, very special use cases for some of these things, but the most popular ones are, of course, fingerprint, face, and iris. Okay. Uh, there are several others in the laboratory stage, like gait, we talked about, the way you walk. Your keystrokes, how you type, can be used for recognizing you. Most of these are for one-to-one matching, and several other, like this is conjunctival vasculature, your blood vessels on your, not on the cornea, but the sclera part of your eyes. Many other things like the ECG signals, regions around your eyes, your ears, tattoos, knuckle prints, even your fMRI, that's getting too invasive in some sense, that the way you think is what is really who you are. And you have to actually start reading your thoughts to identify the person. And I don't know how many people will be comfortable doing that. Used in several other places like ATMs and access control systems, you all of you know, but it has been used in other places like Disney World, or where they want to make sure that somebody who buys a ticket, there are week-long tickets available for Disney World. You take a ticket, you can go back every day for a week, and because there are so many rides and things like that, where it would take a week for you to see everything. So what people used to do, buy a week-long ticket. First day, one person goes. Second day, second person goes. So with one ticket, 7 people will visit Disney World, and they would lose money. So they said every time you take a week-long ticket, you also need to give two of your fingers, the image of two of your fingers, and every time you enter, you need to put those two fingers and make sure that it's you who are entering, not somebody else. So several kind of applications you'll see. And in terms of the market, it's been exploding, and the global biometrics market forecast says that it's to surpass about 82 billion by 2027, despite the drop in sales due to the pandemic. In 2020, it was about 24 billion. It is expected to reach the 82 billion by about 2027. So it's a huge market out there for this one. So that's why a lot of industry research also you will see in the area of biometrics. Okay. So now let's get into a bit more of detail about what biometrics are and what are its characteristics. How do you actually do this? And also I'll try to talk a little bit about three of the primary characteristics: the fingerprint, face, and iris. Okay. Any questions up till here? Okay. Just basic story only at the beginning, but now we get into some of the details. As I said, biometric traits are supposed to be unique and permanent. Those are the two most important characteristics. It should be different between different peoples, and it should be the same for the same person over a period of time. Like some of the characteristics could change over a period of time. Your voice, when you are a kid, is not the same as the voice you once you become an adult. And maybe when you become very old, maybe your voice will change further. So, or if you have a cough or a cold, then your voice changes. So there are several reasons why it may not be permanent or not very stable. Uh, but uniqueness is important and permanence is important if you want to recognize people based on the biometrics. And in this context, the two words that are introduced to basically show this are intra-class and inter-class similarity. Intra means within. So within the class means within the same person. So if I take my fingerprint 10 times, all those 10 times, those samples should be as similar as possible. And inter means between, so between two classes, between two people. I take fingerprint of person A, I take fingerprint of person B, and these should not be similar. They should be dissimilar. So intra-class similarity is a good thing, inter-class similarity is a bad thing. So we want to have as low inter-class similarity as possible, and or you want to increase the inter-class distance. Similarity is the first distance. So those are the two main issues that we are dealing with. We want a biometric with as much as possible intra-class similarity and as less inter-class similarity as possible. Okay? And of course, there are a few other characteristics. We already talked about uniqueness and permanence, the second and third in this list. But the first is universality, that everybody should possess it. If you are talking about signatures, maybe not everybody can sign. Illiterate people may not be able to sign. So signature is not a universal trait. There might be other traits which are not universal. Not everybody in the world might possess a specific biometric. That's possible. Even fingerprints are not actually universal. In two reasons. One is, of course, some people will have lost their fingers or born with a defect where some of the fingers are missing. Or it's also possible that some people are born with a very rare medical condition where some of the people don't have fingerprints. They have fingers, everything looks nice, but if you look closely at the fingers, it's just plain skin. Just like you have skin on the face, the same kind of skin is there on the finger. There won't be any lines or ridges or pores and stuff like that. And you cannot take fingerprints of those people. So that's a very rare condition, but of course, because of loss of fingers and all, you can, the fingerprint may not be that universal, but it's 99.9% of the people have got fingerprints. Collectability is another issue. Like I said, fingerprints are easier to collect, face is easy to collect, but tongue print may not be so easy to collect. Okay? Or DNA is a good biometric, but it's difficult to collect because you have to extract the swab and then process it and take some time to do the capture. Performance in terms of accuracy, how accurate can the matching be? That's a problem. Acceptability, in some cases there might be a problem. Like some people don't want to reveal their faces. So in that case, how do you take a face image and recognize? Iris might be okay for some people. So you see that in some of the Gulf countries, they are okay with exposing their eyes, but not exposing the whole face. So in that case, it's socially unacceptable to capture face, but iris might be okay in those situations. So you need to pick the biometric according to the situation that we are in. And also circumvention in the sense that how easy is it to circumvent, create fake biometrics. So now if we take a quick look at the high level structure, what is a biometric authentication system? First, there is an enrollment phase where you put your fingerprint or whatever the biometric is, you capture it, the sensing part, that's the first step. Next is, you don't want to use the whole image directly for comparison because images can change. If I take my face image right now and I turn to my left and then take the image from the side, both the faces of my images of my face, but they don't look the same. They're pixel to pixel matching. If I do, they don't match. Or if the light changes, then again the face changes, the image changes. But you don't want to worry about all these variations caused by lighting and pose and stuff like that. So you want to throw away those things and capture only information that is relevant to your matching. Okay, and that is called feature extraction. And then once you have those features extracted, you store it in some database. And this is during the enrollment phase when you actually create your entry in the system. And then during the authentication time, when you're trying to enter the room or give attendance, you put your fingerprint again, the same feature extraction happens, and then the features are matched. A matcher is used to match these two and say that whether these two match. And that's what happens in any system. The first time when you set up a mobile phone, they ask you to put your fingerprint multiple times. And every time you do the feature extraction and put all those things together and store it in a database inside. Next time when you do authentication, when you put your finger, it extracts the fingerprint again from there, and then the information is used to match against the database before it unlocks. So that's the process that is going on. And the final answer is just a match or a no match for every single matching that you do. And this representation in classical machine learning terms, you call this as a feature vector, but in biometric, you might also use the word template, because what you're capturing is not a single feature vector, like in the case of fingerprint, we said, while enrolling, you are trying to put your fingerprints multiple times. It's not a single time that is captured. So multiple fingerprints are taken, you extract feature vectors from each of them, you combine all of them together into a single bundle, and that bundle is what is referred to as a template. Okay, so your representation of an individual's biometric trait from possibly collection of impressions is what we call as a template. And multiple templates are often stored in account for observation of variance. And template can also be updated over a period of time. As time progresses, you might, for example, your face, it might slowly change based on, as you age, your face would slowly change. If you put on a bit of weight, your face might change. If you grow some facial hair, then your face might change. So there's also this possibility of updating your template over a period of time. Okay. Now the biggest problem in biometrics, we talked about two of the problems. One is this inter-class similarity, the other is intra-class similarity. But why is this such a big problem in biometrics? Because unlike any other machine learning problem, biometrics is a huge classification problem where the number of classes is very large. Right now in the world, I wrote 6 billion a couple of years back, now 7 billion, touching on 8 billion maybe now. It's more than 7 billion for sure. Okay. There is some studies which say that maybe the world population will saturate around 10 or 11 billion. So that's where you're going to reach over a period of time. So the number of different people are so large that we need to make sure that every pair of people are separable in the feature space. And most of the others we already talked about, but a couple of them might mention that segmentation is a problem. That is, if I capture somebody's face, I want to make sure that everything else is eliminated and only the face is captured. There could also be noise in the data, just like any other signal noise here. Temporal variations, we talked about how your signature changes, how your face changes over a period of time. And population coverage and scalability, based on that, the accuracy, how much can you scale up, and system performance in terms of speed, in terms of cost, error rates. All these are issues that need to be taken into account. And of course, there can also be attacks on the biometric systems. Like somebody can put in, now apparently in Hyderabad, some of the places you can go and buy your fake fingerprints. You give your fingerprint, they will create a fake finger for you. Students or company workers will give this fake finger to my friend. When they go in, they'll punch in with my fingerprint also, and I get attendance. So all this kind of issues are there. So people are now working on methods. One of my areas of research is to figure out how to detect and prevent the use of fake biometrics. We already talked about this issue, so I'm going to skip this intra-class variability. As I said, the face image could vary based on your pose, your expression, your whether you're wearing spectacles, all those things. And same thing with your handwriting could change quite a bit. There are also similarity issues that two people can look alike, like this identical twins. They tend to have very similar faces, and people still haven't figured out why this happens. But there are some places like this village near my hometown. They have 2,000 families living in that village, and about 400 identical twins in that one village. There are some strange pockets of places where this thing seems to be somehow more. identical twins are formed. It's slightly different from twins. Twins are born for different reasons, but identical twins are born when actually one single person is formed initially as a single uh, zygote is formed, and then for some reason it gets split into two. At the very early stages of pregnancy, the single zygote gets split into when the cell division happens. When the division happens accidentally, it breaks apart and becomes two different zygotes, and both of them grow into full individuals. And because they start from a single cell, they have exactly the same DNA because only a single DNA was formed. And the split of the cell was when the twins happened. So because of that, even if I use DNA to match, identical twins will exactly match. But fingerprints and face tend to have higher level of similarity. Fingerprints are quite useful here. There are also similarity between father and sons, and of course it need not be only twins, but also possible to have triplets. Same way the zygote can split into three or can get split twice. That is also possible. Okay. So these are all reasons why you will have this kind of similarity. That is an issue. The second issue, another issue that we talked about before was noise in the signal, in the sense that noise is not just electronic noise, but also noise introduced due to contact between your fingerprint and the sensor. If your hands are dry, then sometimes your sensor doesn't work. Sometimes you realize that I put my finger here and it says not recognized. But now I'm trying not to recognize, it is recognizing. But yeah, sometimes if your fingers are dry, sometimes you touch, or your hands are wet. If you are working in your kitchen and I'm trying to unlock my phone, it doesn't work because hands are wet at that time. So there are reasons why you may not, your sensors may not work at a certain time. Okay. Uh, Now, I'll mention one more thing before I move on to the specific biometrics. But any questions up till here about the basic challenges in biometrics and issues related to it? And then we will get into evaluation of biometrics and issues related to specific biometrics like face, fingerprint types. Any questions? People at the back. Need not be only related to what I say. You can ask questions in general about biometrics. It's fine. Okay, good. So let me move forward. Uh, how do we evaluate the performance? How do you know how good a biometric is? Okay, and to do that, the overall performance of a biometric system can be assessed in terms of its accuracy, speed, storage. Several parameters could be measured, and also factors like cost and ease of use can also affect its efficacy. So you need to evaluate several things, but the most important thing that people normally evaluate is the accuracy. But then accuracy itself is not a single number. So we need to get a little bit more into detail with that. Biometric systems are not perfect, and it will sometimes mistakenly accept an imposter as a valid individual, or it's called a false match. That is, I take somebody's face and my face and try to match them, compare them, and sometimes incorrectly they might match because of several reasons. Like a case of father and son, we said, or identical twins, we said, when they are not supposed to match, they falsely match. This can happen sometimes, and that's called a false match. Or conversely, the reverse, when I take two faces of my own, two images of my own face, and then try to match and see whether they match or not. And you see that they don't match, and it's called a false non-match. Okay, so these are the two kinds of errors that can happen. One is somebody should not be matched, does get matched, and the second is somebody should be matched, or two images that should be matched does not get matched. And these are two different issues. And based on this, we can actually measure its accuracy for verification. We call these as genuine pairs and imposter pairs. Genuine pairs means pairs of biometrics that's supposed to match. So I've color coded it to say that, okay, colors are supposed to be the ground truth. So blue and blue means that they are images of face or fingerprint, whatever it is, coming from the same person, coming from the person blue. They are supposed to match. orange and orange, supposed to match. Green and green, supposed to match. Yellow and yellow, supposed to match. So these are called genuine pairs. Pairs of images coming from the same person, not even same person. Like if you take your fingerprint, for example, all your 10 fingers have got different fingerprints. So your fingerprint from your right index finger should not match with the fingerprint from the right middle finger or the left index finger or whatever it is. They are all supposed to be different. Okay, so that is genuine pairs are images coming from the same fingerprint, same finger or same face. Imposter pairs are pairs which are not. So I take fingerprints coming from two different fingers, they are not supposed to match, or fingers coming from two different people, they are not supposed to match. They are imposter pairs. Okay, and basically you need to compute some kind of distance measure for each of this, and the hope is that between pairs, the similarity value, here I'm talking about similarity, the similarity value is supposed to be high, and between imposter pairs, the similarity value is supposed to be low. But these comparisons are not perfect because of changes in phase, because all these kind of issues that we talked about. So these numbers won't all be very high for genuine and very low for imposter. That doesn't happen. So once in a while, you'll see that some of the imposter pairs will have a high value like 44, and some of the genuine pairs might have a low value like 43.5 here. So it's possible that a genuine pair has got a lower similarity value than an imposter pair. And this is where the problem starts. Now the question is, if I have these numbers, when do I start calling a particular pair as genuine or imposter? Okay. In this, by looking at these numbers, maybe I'll say that the threshold is 43 or 44. If I keep my threshold as 44, then one of these genuine pairs will have a lower value than 44, so they will be called as a non-match. That's what we call as a false non-match. And that particular pair at the top is 44.6. That has got a higher value than 44, so that's called a false match. Okay, and to understand that, we can actually do some kind of a histogram or probability plot and see that the genuine distribution, it won't be a single number. All the pairs of matches that you take, you'll have some spread, so you can plot some kind of a distribution function over it. And similarly, I can do a distribution function over the imposters. And the hope is that these two distributions are well separated. Okay? That there is no overlap between them, but that doesn't happen usually. Usually there will be some overlap between those two distributions, and here is where all the issue happens. So at that point, there will be some threshold that you need to decide, to the left side of which we call it as imposter, and right side of it we call it as genuine. And that threshold we need to figure out. And depending on the situation, we might actually choose different thresholds. For example, if I'm working in a high security military situation, I want to make sure that the imposters are 0. I don't want somebody else to get access to my military systems. So I'll put a very harsh threshold in the sense that my matching score, I will put it over here. Sorry, imposter should not be accepted. So I'll put the threshold to be very high. So if it's an imposter, it would be below that. So I put my threshold all the way up to, let's say, 50 instead of 44. So that only genuines would be accepted. It's possible that some genuines might be rejected. That's okay. If I'm putting my fingerprint in a military installation system and it rejects it, I need to do it 3 or 4 times before I get access. That's okay. But a wrong person getting access is not good. So I'll tend to push my threshold high if it's a high security application. But if it's my mobile phone, every time I want to unlock, I need to put it 5 times. I'll just remove my fingerprint and say that maybe I'll put a pin instead. So there are other situations where the cost is not so high. I'll put a lower threshold. Okay. So essentially, the system performance can vary based on the threshold that you put. And one of the ways to represent this is by putting multiple thresholds and then plotting some kind of a plot. So these are the regions underneath it, are what we call as the false accept rate and false reject rate. And based on these things, I can, by changing the threshold, I can plot a curve, which is what is referred to as a receiver operating characteristics or ROC curve. There are several ways to call it. This particular one is called a VET curve, and the way in which you plot it, whether it is FAR versus FRR or other ways, based on that you might call it by different names. DET curve is what is FAR versus FRR. If I plot FAR versus GAR, then it's called a ROC curve. It's the same thing, it's just flipped. It's almost like the other picture is like a flipped variant of this one. Okay, so you get one, you can compute the other from it, so it's easy. You can also plot this in a log scale, which is very common. Log variant, semi-log variants, like one axis is log and the other is normal. So these are some of the examples of real ROC plots or semi-log ROC plots, and based on this you can decide whether one system is better than the other or not. You'll have some systems with a higher curve, which is supposed to be better, and the lower curve is supposed to be not so good. Okay, so that's the ROC plot there. Now, in practice, if you look at, let's go back to this slide here. In practice, these systems have become so good that it's not, these two distributions have now become so far apart in most of the good biometrics that if you plot my ROC curve, it is getting very, very close to ideal. Like you can see in this example, all the plots are clustered at the top left corner there, which is supposed to be the ideal curve when there is no overlap between the systems. Okay, so now people have started talking about things like FMR 1000 and FMR 10,000. That is, if I put my threshold so harsh that the false match rate is 1 in 1000 or 1 in 10,000, then what is the false reject rate? So these are the kind of metrics that people are using right now. Okay, so this is basically about the evaluation. So this is what typically you would see, these kind of numbers is what you see for a real world system. So you can see that in the case of fingerprint, FMR 10,000 is 0.08%. That is, if I allow a false match rate of 1 in 10,000, that is, 10,000 people come and try to unlock my phone, maybe one will succeed. That is the level of security I want for my phone. Then the chance of my phone rejecting my own fingerprint is 0.08%. That is still less than 1 in 1,000. So it's a very, very secure system that you can build. Of course, this is based on high quality fingerprints, with the quality of fingerprints going down and the quality of sensor being as low as in the case of phone, it doesn't work. These numbers are based on high quality fingerprint sensors. Now, just want to get into the most common biometrics, but once again, any questions before that? If you don't have any questions, then we'll get done fast. Maybe that's a good thing. So this was a poster that was brought out by one of the institutions, which was right next to my institute, IIIT. Just across it, there was this company called CMC. I don't know how many of you remember that. It is now under Tata TCS. So CMC had a fingerprint recognition system, and this was their advertisement. It says that faces can lie, but fingerprints never. This is covered up a little bit here, but what do you see here in this picture? So if you look at all these people, it's all the same person. All the picture of the same person, same actor who is dressed up differently. Okay, so from first look, in several cases, it may be difficult to say that the person who is at the top left is the same as the person who is top right, who is same as this guy and stuff like that. So this point is that face can be changed quite a bit based on their makeup and stuff like that. And their claim was that fingerprints don't lie like this. It's difficult to create variations of the fingerprint like in the case of faces. And faces, there might be genuine reasons why your appearance changes. Like several of you might be putting up makeup, and makeup can slightly change the appearance of your face. If it doesn't change the appearance of your face, why do you put makeup? So it's okay to put makeup in the sense that it is socially acceptable to change the appearance of your face. Whereas it may not be acceptable to change the appearance of your fingerprint. That you don't do normally. because it is done with the purpose of evading a security system. So naturally, there could be more variations for your face. So now when you talk about fingerprints, I'll quickly look at each of these modalities, and then based on questions we can take it forward. But I'll do a quick overview of the three modalities now, and then I'll stop. So first is fingerprint, then there are two more, iris and then the face. So when I say fingerprint matching, what do you mean by fingerprint? Many of us actually don't look deep into it. All of us we carry around 10 fingers all the time, 10 fingerprints. In fact, you also have prints on the toes. Each of your toes, if you take a look at it, there is print on the toes also, which look very similar to the fingerprints. So that is also an issue. But collectability of toes is difficult. If you are wearing a shoe, especially, to capture your toe print would be far more difficult than capturing a fingerprint. So what is fingerprint? Every finger has got a graphical flow like rich patterns that are present in the human fingers. So if you look closely at every one of your fingers, you will see that there are these lines that are going on the fingers, and that's what creates your fingerprint. So it's not just that you have a smooth skin on your finger. There are these lines that you see at the top right here. They are ridges and valleys. There are highs and lows on the skin, and these are formed for some natural reason. Why is it that you have prints on your fingers but no prints on the face or the back of your hand or on your arms? You don't have prints, you don't have lines like these ones. Why is it that only your fingers and the bottom of the toes, they have these prints? Any reason? There is an evolutionary reason why we have fingerprints and palm prints and toe prints. Any guesses? The primary reason is this: your grip. When you hold something, why is it that you're able to hold it with just two fingers? If I try to do with the back of your fingers, it slips much more easier than when you hold it with the front of the finger. And the reason is that these ridges, they act like they are friction ridges. They create more friction because of it. It's able to squeeze and it's able to deform and get into the shape of the object that you're holding, that it's able to capture. Even when you're capturing something like this, I'm actually holding onto this bottle where the two sides are like this. It's purely based on friction. I'm right now holding this one. And of course, when you're walking also, you need friction. That's why there are friction ridges at the bottom of your uh, legs as well, your foot as well. So this is designed for that purpose, or this is evolved for this purpose. But because the process of evolution of these ridges for a particular human, from the stage in which you are an embryo, when you're growing, when you slowly start growing your fingers, and then slowly get your fingers, and when the ridges start forming, that is actually a very random process. So the way in which the skin is formed is due to a random process. Some ridges start taking shape here and there, and then slowly it grows and covers the whole of your finger. And because it's a random process, when you repeat it the next time, it doesn't happen exactly the same way. There will be some difference. So there's a difference between every one of your fingers, and there is difference between every pair of fingers if you take between other fingers. Okay? And that's why this became unique. So what is unique? If I take two fingers, how do I decide whether they are different or not? The first thing that you would notice, if you take a close look at your fingers, very difficult to see, at least at my age. I need even if I put a spectacles and then look closely, you can probably see, but most of you have mobile phones, so if you take a picture of your finger and zoom it in and see, you will see that you can see the lines. So what about the lines make it unique? Okay, it is believed to be unique for every person, and it also has a very long history. People have used fingerprints from kind of known the fact that fingerprints are unique, the fact that you can see fingerprints kind of imprinted on some of the. There's a lamp, a Palestinian lamp from about 400 AD, and there are even pottery from even before that in which people have seen fingerprints. not just accidentally put there, but purposefully put there by the person who is making the pottery as a seal of their own, the person who is making it. So people have known that fingerprints are kind of unique. Uh, Potters might have first noted it because when they touch, you leave fingerprints, you can visibly see. But so it has long history. But what about these fingers are unique is a question. And the point is that what is unique is not just the overall flow pattern. So if I look at these two, you see that there is quite a bit of variation there maybe, whereas if I take these two fingerprints, they look far more alike. The overall flow pattern seems to be very similar in these two cases. They are not so similar, they are similar, but not as similar as these two in here. Okay, but these two fingers actually belong to the same finger, these two belong to different fingers. They are not the same fingerprint. And therein lies the detail that it's not just the overall flow. In fact, the overall flow, there are only very few. You can actually classify the overall flow into mostly the 6 categories. So there are, if you look at every one of your finger will belong to one of these 6 categories called, this is arch, tented arch, left loop, right loop, uh, and whole. There are 6 such things. So this is arch, this is tented arch, there is left loop, right loop, whole, and there is double loop. So each of your fingers will be one of these 6 categories, most of it. Okay, 99.99% it will be one of these. There are slight variations of this, but you can basically say it belongs to one of these 6 categories. And folklore says that the most perfect, this is not science, okay? Folklore says that the most perfect fingerprint is a hole, which is this one. It looks like a circle. All the ridges go like a circle in the middle. And there's even some of the cultures which believe that if you have holes in all 10 of your fingers, then you are somebody special. Okay, you are the chosen one. Uh, I don't know. I have only 4 or 5 of the fingers have got holes, but all 10 folds I've never seen anybody having it. So you can try and find out whether you are the chosen one if you look at your fingers and find all the 10s are circular shapes. Uh, but these are the 6 types, so which means that it's not very unique. Multiple of your fingers will have the same flow pattern. So flow pattern by itself does not decide uniqueness of fingerprints. You need to go a little bit more detail. You need to look at the individual lines and say that when you look at the lines, you'll see that the lines will go like this and then suddenly stop at a certain point. Some of the lines, ridges will go and suddenly stop. Some of the ridges will go and then suddenly split into two. So these two factors you will see if you look very close. It's very difficult to see with your naked eyes. You'll have to take a picture of it, or you take a fingerprint, enlarge it, and see. You will see this kind of patterns. So ridges abruptly stopping, or some of the ridges splitting into two. And these are called ridge endings and ridge bifurcations. Now, what is unique between two fingers is the location of these splits and endings. So where does the ridges end? So in one person, there will be ridge endings here, 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 and here, and bifurcations at certain other places. Whereas for a second finger, the location of these would change. And these special points where the ridges either bifurcate or end are called minutiae, written as M-I-N-U-T-I-A-E. This is the plural. Okay. Minutiae is the plural. Minutia is without the E is the singular form. So the distribution of these minutiae is what makes a finger unique. So your feature extraction process is essentially trying to do some image processing, doing some filtering. By the way, all your signal processing can be used for this purpose. So you are looking at these patterns and you need to extract this with a lot of noise in it. So you need to first think of a filter that can pass only the ridge information and suppress all the noise information. And fortunately, the fingerprint ridges have got a very certain frequency. The spatial frequency is not very different between people. It doesn't change much. So given a fingerprint, I can identify the spatial frequency here and then use a filter, basically a bandpass filter, which will only pass the frequency that is corresponding to these ridges and suppress everything else. And traditionally, we know that there are two issues here. First, the frequency has to be decided. Second is the direction of the frequency is different at different places. So I need filters which are oriented at different directions at different places. We need local frequency and you need local bandpass filters. And we know from signal processing literature that the best way to extract local frequency, which a frequency that is both localized in spatial domain and frequency domain, the best combination of that is obtained is using a Gabor filter. So Gabor filters are what are used to extract that information out of here and suppress all the other ones. So you do this Gabor filtering. So Gabor wavelets are basically one form. There are several other wavelets that have been tried out, but I think for fingerprints, the most common ones are Gabors. Now, in modern day, people have now moved on from using traditional filtering and stuff like that into deep learning, in which the first layers of the deep learning network are basically convolutions, and you let the algorithm learn the filters, and it turns out that those are very close to Gabor filters. You can actually look at the learned filters, and its shape looks very close to Gabor filters. So that seems to be the truth. So, I mean, that part there is very little research now left out in that aspect, just based on what filtering you should use. That is reasonably well settled, but still the orientation of it. The problem is that when things are noisy, if this is very noisy, it's very difficult to figure out which direction the ridges are going. If I know which direction the ridges are going, I can filter it. But figuring out the direction is not so easy. So people have used, more higher level concept, higher level information, either learned using a deep learning network or otherwise extracted to guide your filtering process. So your wavelets are, the direction of the wavelets are chosen based on some high level information from them. That is true. But yeah, low level filtering is still about wavelets. Now, once you do that, your fingerprints get cleaned up. You get much cleaner lines, and then it's very easy to detect these bifurcations or endings. And then you take that, you get a set of points. These blue, the red and blue are two instances of the same finger, and the thick dots that you see here are the minutia points. And you want to align the two. You need to take two fingerprints. You need to align them before you match them. So there are some algorithms like Hungarian matching and so on, which is used for that purpose. And then you ask the question, how many of these minutiae match? So if the number of minutiae match is more than 7 or 8, then it is considered to be matched. I think in the court of law, if when say that you left your fingerprint at the crime scene, it is your fingerprint. As a fingerprint expert, looker is going to say that it's your fingerprint. The number that is used is some number like this. If it is more than 7 or 8 minutiae that is matches, then you get caught. And there have been cases in which wrong convictions have happened. So that is an issue. Of course, the more the number of minutiae matches, the more sure you will be that it's actually you. In some cases, this has happened that some of the experts just said that yes, it is a match based on. This has happened that some of the experts just said that yes, it is a match based on. Many times they are biased by other evidences. Somebody would have said that, oh, I've seen this person here. Somebody else would have said that, oh, this guy lives next door. They had a vendetta against this person. All that plays in your mind, and then you decide that, oh, 7 is enough now. But there have been cases in which that has been shown to be really bad, especially when you're doing 1-to-n matching. There have been cases in which a doctor living in Michigan, where I was doing a PhD, nearby there, a doctor was convicted of a crime he committed in Europe when his fingerprint was lifted from his doctor happened to be a Muslim person, and there was some bombing in UK and or France, I forgot somewhere, and the fingerprint was lifted and matched against the database. They also sent the fingerprint to FBI. They searched against all the people who are immigrants, and this person's fingerprint matched. And unfortunately, he also happens to be a Muslim. And then that says that, oh, this guy should have traveled there and done this. Whereas he was actually practicing, he was a practicing doctor. He was happily living in Michigan, treating patients. And took a long time for him to convince the courts that it's not him he never traveled to Europe at that time. So things can happen if you put the wrong percentage. Just to see one more example, that at our first look, naked eye, it might look all three are the same, but these two are actually matching and the other one is not matching. And based on overall appearance, you might not figure out there is so much of difference. But if I use minutiae to match it, the matching score between these two is 97. The matching score between these two is 5. The matching score between the first and last is 2. So there's a huge difference in matching score when you look at the minutiae level detail. So that's where the uniqueness actually lies. Okay? And you might also create false minutiae due to noise. That noise would, like cuts and bruises, can create false minutiae, so you need to take care of that. So typically what you do is you do some kind of enhancement. The filtering process that we talked about is the first stage of enhancement. Of course, there are better methods that are existing now, mostly deep learning. I'm not getting into deep learning for this one at this time. Okay. So with enhancement, you see that the ROC curve typically tends to become better. You already see that the ROC curves are so high up, it's getting close to ideal. And that is even after putting this at the log scale. This is 10 to the 1, 10 to the minus 3 here. So even at that level, the accuracies are quite high. But of course, fingerprints have limitations due to the cuts, bruises, oily finger, dry finger. All these things can create problem. Wear and tear of sensor is a problem. If multiple people use the same fingerprint sensor, you touch it many times, you'll have issues. About 4% of the fingerprints are not supposed to be of good quality because of several reasons. Dry, some people have naturally dry skin, they will have a problem with it. And also requires user habituation for good performance. If you use these fingerprint sensors often, or whatever sensor you're talking about, you tend to become better at providing these fingerprints. And that's another reason why initially it might not work very well, but over a period of time it gets better. And new compact and solid state sensors capture only a small portion of the fingerprint, like what we said about the phone. When I put my finger here, it only captures a very small portion of my finger, and based on that, it's trying to recognize. And that means that there is a higher chance of false match or false non-match. The other two biometric, I'll quickly go over it. They are based on iris and face. Iris is basically whatever is inside your eyes. We'll get into the iris, but overall, you can say ocular biometrics is everything related to the two eyes. It consists the ocular region, eye and its immediate region correspond to the iris, the central portion of the eye, the sclera, the white region around that, the eyelids, eyelashes, eyebrows, the skin around that. All that will contain identity information. We have recently published a paper. It's yet to appear. It's about to appear in the International Joint Conference on Biometrics next month, next to next month, where we say that iris is this portion of the eyes which has got the color. Like people have black eyes, black iris, or brown iris, or blue iris. When you say blue eyes, somebody has got blue eyes. What do you really mean? The whole eye is not blue. It's the iris part that is blue. Okay? So that's the portion that we are talking about. But interestingly, the portion around it can also be used for matching, even though not as accurate as the iris itself. And we recently figured out that there is a mechanism to actually do securing of the information using that information that is around your eyes. So the iris is the matching part, which figures out the identity, but the region around it can be used as a mechanism to communicate between the authenticating parties without a third party being able to figure out. So it's some kind of a encryption going on where I can authenticate with the system in the net by using the region around the eyes, but that will not reveal any additional information about the iris itself. So that's one interesting aspect that we can discuss. So what is iris? As I said, it is that part of the eyes which is sitting in front of your lens. This is the eye, and +2 biology picture or 10th class biology picture, which you have the eye lens, and then in front of the lens there is an aperture which can open and close, and that aperture blade, the diaphragm, is what you call as the iris, and the pattern of that is supposed to be unique. These are different examples of patterns that you see on the right hand side. Different types of irises are present based on the kind of muscles and tendons and all that is going on inside it. So iris is the annular region of eyes bounded by the pupil, the hole in the middle, and the sclera, the white region around it. And the visual texture of the iris, it stabilizes during the first 2 years of the life. So you cannot use iris for infants. Up to 2 years, it's not sure whether how stable they are, but after that, it's very stable. Iris also has got is unique, and even irides of identical twins are different, like just like fingerprints, because there is a random process going on that is very different. And the details of it. This is a text from Professor John Dogman. He is still the authority of iris in the world. He proposed the first iris recognition system, and he has given a nice detailed, uh, explanation of what iris is almost like poetry. The way he writes a definition of what an iris is. Iris exhibits a very rich texture consisting of pectinate ligaments adhering into tangled mesh, revealing striations, ciliary processes, strips, rings, furrows, corona, and sometimes speckles, vasculature, and other features. I'm reminded of the definition of what a book in Three Idiots movie, Amir Khan talks about what a book is, and uh, description of what the book is. And, it's like all the finer details all put into a nice single long definition, and that's what John Dawkins has done here. So it's all these variations that you see is based on this random processes that is creating this iris pattern. The problem is that for most of us, when you look at our iris, I don't see any of these things because most of our irises are dark in color. We have dark eyes. In Indian culture, dark eyes is supposed to be beautiful. In European system, maybe blue-eyed boy is supposed to be somebody who is special. So for them, blue eyes may be special. For us, dark eyes are supposed to be good. I forget one of the popular names of females. This thing is it says dark-eyed, and it's supposed to be used in as a symbol of beauty. Uh, but how do we do it? We cannot see all these details when you normally look at it, all the layers that you see and the details, because there is this stromal pigmentation that happens. The pigmentation is the one which hides this pattern. And the primary function of the iris is to control the amount of light that goes into your eyes. So this aperture which your pupils open up and close because of the muscles inside the iris. That's what actually the use of it is. And we are going to make use of it for person identification. And the way you do it is essentially using infrared imaging. So if you look at the original image, it might just look like a brown patch or a black patch, but you can get far more detail if you image this thing under NIR. So near infrared imaging, around 750 nanometer to 860 nanometer range. If you take, you will see all the patterns which are underneath. The pigmentation that is present does not affect NIR illumination. So you can actually see the details using that. Using that, you would get all these kind of nice details, and based on that, you can, again, the way in which it is captured is using classic signal processing techniques, a set of wavelets, which are run on this pattern. You take this pattern, you open it up, and then run these wavelets on top of it, and based on the responses of the wavelet, whether it is high or low, you get a 0 or a 1, and you get a binary code for your iris, and that's called an iris code. This is John Dogman, at least how he used to look in 1990s. Again, he proposed Gabor filters for this purpose with multiple orientations. You can use other wavelets as well. They've all shown to be very good. And the matching algorithm is very simple. You take, once you have two bit vectors, you just take the Hamming distance between them, and that's what the distance is. You might also use some mask to mask out some of the ranges, but otherwise it's a simple Hamming distance. And for imposter distributions, if I take two bit vectors, the probability of two bits matching is at random is 0.5. So 50% chance that randomly selected 0 or 1 would match the other. So if I take the Hamming distance for imposter pairs, you will see it's a distribution centered around 0.5, whereas for genuine it would be much lower. The distance would be much lower. So that's the basic idea, and you very high accuracy using iris. There are a lot of data sets that have been that have come out in the case of iris, and you will see that the number of images and subjects are, some of them have got irises almost of the size of 1 million images. The Cassia V4 has got 1 million images in that. Just to,
Is it freely available, sir?
that's a big problem. Most of the biometric datasets are, most of them are freely available. They are now going out of this set because people are getting more and more concerned about their privacy, that most of the biometric datasets are being pulled down. So even things which were freely available now are not. Face images are still, datasets are still available, but iris and fingerprints are getting more and more difficult. So people are slowly looking into ways to get around this one. We are also trying to build a system, at least within IEEE, where we can collect biometrics and keep it in the lab itself, but others can access it to run it, but not take the biometric out, so that the security is not violated, but the privacy is still respected, but still research can go on in that. So that is becoming a bigger and bigger problem. So what is happening now is that only those labs which actually collected data, they have the data, they can do research, but nobody else can. So it's a bigger problem, practical problem coming up in the field of biometrics. Just to wrap up this, I'll stop with this one. Yeah, passing 5 o'clock. There is this famous story of this girl, this picture. I don't know how many of you have seen this picture. Maybe you recognize this. It was on the cover of one of the National Geographic's edition. This is 1984. This girl, at that time, her age was 12. She looks probably older than 12 at that age, in that picture, but she was only 12 years old. She was a refugee in Pakistan during the Afghan war. She was an Afghan girl who fled to Pakistan with her family. And this is not a posed picture. Okay, she was just walking around. This guy Steve McCurry was a journalist. He was walking around. He saw this girl, and there was something about her that caught his attention. So he just took his camera and took a picture. And that look on her face says a lot. The hardships that she has gone through, and because of the war, the young age, her face says a lot of trauma and sadness and stuff like that. And that became a very, very famous photograph. He won the Photograph of the Year, Journalist Photograph of the Year award for this picture. And after about 18 years, he wanted to go back and find this girl and to figure out what happened to her, because this was just a girl who walked by in the refugee camp. He wanted to go back and find her, and it was a very, very difficult journey because he didn't even know what her name was. He never talked to that girl. He just took a picture and walked away. And later on, when he developed the film, those days it was film photography, he realized that this was such a nice and captivating picture. Uh, but how do you go back and find? The only thing you know is that she was a refugee from Afghanistan who went into Pakistan, and now you don't know whether she is in the border of Afghanistan, Pakistan, where she is. So he went to scout and figure out where she is, and after a long search of several places, several people saying, "Oh, this is this particular girl." There, he only has this photograph. So you are showing this photograph and said, "You know this girl," and took a long while to find out. And at some point, finally, he figured out that this is the girl. Remember, original picture at the age of 12. This is the picture 18 years later, which means she was 30 at that time. She looks, of course, much older than that, at least in our eyes. It doesn't look like a 30-year-old woman. She had several kids. She is living okay, not in a great situation, but in some remote part of Afghanistan, finally he was able to track them down. Question is, how do we still figure out it's the same person? And what he did is he took this picture and sent it to John Dogman in UK, and he extracted the iris patterns from these two and tried to match it, and he established that it's actually the same person. Because several people came but to claim that it's me, with the hope that they'll get some money out of cheap metal. So, but finally he was able to do it using iris identification. They were able to match. Otherwise, face matching, very difficult to say it's the same person. There could be many people with the same. Okay? So it turns out that the Hamming distance between the two, the left eyes and the right eyes were 0.24 and 0.31 respectively. Remember, your Hamming distance is 0.5 for random matching, and this is not with iris cameras. This is using normal camera. So because she had lighter eyes, we were able to do this matching. Okay, so that's the story of, and her name turned out to be Sharbat Gula. And because we were able to match and find out, now you know the name of that girl. So iris matching was used in this purpose. Of course, the third biometric is face. I'm not going to talk about that right now, but face matching is something that all of us know very well. It's used all the time. Any of you use social media, you post something in Twitter or Facebook or Instagram, people automatically detect faces, matches, and all kinds of things are going on. So that's an area of very hot research. That is the topic of at least one whole lecture. I don't want to get into it. Okay, so we'll stop here. If you have any questions, I'll be happy to answer. Okay. Last 5:05. I was given 1 hour 15 minutes. I took 1 hour 20 minutes already. So, in case you have any questions, I will. That is, the question is, what is the one with highest security? It's kind of difficult to say. Dogman always claims that iris has the highest security for multiple reasons. One is your iris doesn't get worn down like in the case of hands. You use the hands in working on things, and you can get cuts and bruises. You don't get cuts and bruises in your eyes. You guard your eyes with all your life. So the chance of you getting a high quality iris is very high. The problem is, there are two problems. One is if you have cataract and if your eyes are clouded, then it's difficult to capture, number one. Number two, even when it's not there, when you actually try to stand in front of an iris camera, your eyes can move very fast. And your iris also dilates and contracts. So getting a clear picture of the iris is difficult. Once you get a high quality picture of your iris, the security is very high. The accuracy is very high. The chance of cross matching is low. It's a very nice biometric. So if you have a mechanism, for example, to rest your eyes or maybe put the camera against your face, which is what is done in Aadhaar kind of systems, you see that the iris camera is placed onto your face so that the relative motion of the head and the camera is avoided. But still your eyes can move left and right very quickly, and your iris also has this tendency to open and close. Even if there is no light illumination change, your iris tend to kind of pulsate. Every 1 second almost 1 second it opens up and another second it closes down. It has this nature of opening and closing. So because of all that, it's possible to get the image to be blurry. And once you blur, some of the frequencies are lost. The low pass filtering, blurring. So higher frequencies are lost, and because of it, it doesn't give that much accuracy. But otherwise, iris is really good. Nowadays, in practical systems, face recognition has reached a level which is very close to iris. Iris and fingerprint are supposed to be very close to each other. Face is also now becoming very close to that. Of course, you have two iris, you have 10 fingers. Well, out of the 10, these two are not as good. The little finger and the ring finger are not as good, but at least these 6 fingers give you very good accuracies. Same thing with the case of each iris. So you can say that the amount of information in one iris is almost equivalent to the amount of information in a thumb, which is equivalent to the amount of information in the face, approximately, at least with the technology that we have. It's very close to each other. Depending on the situation, you might. So if you have people who are, office workers who doesn't work outside, your fingerprints would work very well. But if you are working with farm laborers or daily wage workers who work on the field, iris would be the best bet. For commercial, for common civilian applications, face can be very good because it's easy to capture.
Face is there. Different persons can automatically recognize same person before.
I'm sorry, I didn't understand the question.
Just two persons will be there. The second person will come for your attendance. And automatically recognize.
You can do that with face also. You can do that.
Instead of our face, that person's attendance.
So if you can recognize the person, like if you come and say that you sit there in the class, I can take your picture, and if I can recognize your face, I'll mark your attendance, not my attendance. No? So if I can recognize every single person in the classroom, you can do that. I mean, as teachers, I don't do it as well because I usually have, nowadays most of the classes I teach are like 200, 250 people in the class. But I used to have a teacher who used to come and teach for the whole class, and at the end of the class, he'll just call out the attendance, not just everybody, but only the absentees. He'll say today's absentees are A, B, and C. That's it. He would have, in the mind, taken the attendance. He would have looked at everybody. He would have counted the number of people, seen how many are missing and who was missing. He'll figure all that out during the class. So there are some people who are better at probably facial recognition than others, but current face recognition systems of computers are better than what humans can do. So it's, for a small class, it's possible to do attendance based on face view. But small means like a couple of hundred is fine. But if you're talking about several thousands, then the chances of errors goes up. In case of something like attendance, it doesn't matter. Yeah. 1 or 2 errors, unless that attendance actually causes some big issue, usually face is pretty good. So for several applications like phone unlock, face is a very popular one nowadays. Okay. If you have no more questions, thank you. We'll stop here. And then,
Hi all. I feel honored and privileged to get an opportunity to propose a vote of thanks for this session. On behalf of General Chair, Co-Chair, Programming Chair, coordinators, co-coordinators, participants, and on my behalf, I convey my deep regards, thanks to today's session speaker, Dr. Anoop M. Namboodiri. Thank you, sir, for this wonderful session on biometrics. Biometrics is the most suitable means of identifying and authenticating individuals in a reliable and fast way through unique biological characteristics. Anoop sir specified how to deal with passwords, how to avoid weak passwords, how identification is different from verification, and how it is difficult to do for identification with respect to verification. And also he specified importance of biometrics in this today's technological world. Sir emphasized on characteristics of the biometrics, and also Sir provides insights of biometric authentication system, challenges we face in biometrics, performance evaluation of the biometrics, how much it is important with respect to accuracy, and also how we use the minute matching algorithm for fingerprint verification, which is introduced by in this session by Anoop sir. Personally, I came to know about the Personally, I came to know about Vatican system, minute matching algorithm for fingerprint, and also biometric characteristics like persistence, universality, performance, or acceptability. All these things today I learned about it. I hope this session had created sufficient interest among the participants in the field of biometrics to carry on their research. Once again, I thank you, sir, for this session. Let's honor Dr. Anoop, sir, with a virtual memento. Thank you, sir.